Alright, so I'm making this video because I felt that I didn't do as good of a job explaining how to sketch these graphs. So we're gonna look at the graphs in this video. Alright, so now I'll try to give you a more systematic approach on how you can draw the graphs. So suppose you have something like y is equal to 2 cosine of x. Alright, so how do you draw this? Well, first of all, if you have something like this, first look at this part. What does this tell you about the phase shift? There is no phase shift because there is no plus or minus phi, right? There is no phase shift. So that means there is no horizontal translation. There is the period is still 2 pi. It does not change, right? Because nothing is only 1 multiplies x. So the period does not change. What else? There is no vertical shift as well. So there's no plus c here, right? So no vertical shift. So you can always note these information down. That means principal axis is at y is equal to 0, right? And now this gives you that the amplitude is equal to 2. So that is all that you need to know. The amplitude, it's a regular cosine graph with an amplitude of 2. So if this is y is equal to 0, right, that is also the x-axis, y, right? So cosine of x has a graph. So your amplitude is 2. So your maximum is going to be 2. Your minimum is going to be -2, right? And cosine at 0 starts. So if you put 0 here, 2 times cosine of 0. So you also want to plug in some values to check. It's going to be 2 times 1 because cosine 0 is 1 is 2. You start at 2, and then when you go to pi by 2, plug in pi by 2 here, you're going to get 0. And when you go to pi, you're going to get -2. When you go to 3 pi by 2, you're going to get 0. And when you get to 2 pi, you're going to get 2 again. So it's your regular cosine curve. Remember, cosine pi by 2 is 0. Cosine pi is -1, and 2 times -1 gives you -2, right? And cosine 3 pi by 2 is 0 because it's an odd multiple of pi by 2, and cosine 2 pi. So your graph is just your regular cosine curve, but rather than being restricted to 1, you're restricted to 2. So 2 pi is just 360 degrees, right? So you can use your axes in degrees as well. So 270, 180 degrees, and 90 degrees. And this point is 0 degrees. All right. So this is how you do it. So your amplitude is 2. So instead of going up 1 unit, you need to draw from 2 units and 2 units down. All right. So your graph, your graph looks something like this. All right. So that is how you do this question. Now let's look at a few more examples, right? Because we want to get very, very familiar with this. All right. So how do you do this part? Y is equal to sine half x. What is the amplitude? Well, my amplitude is still 1, right? Because it's just 1 multiplying. What is my period? Period is, well, 2 pi divided by half. And that gives me 4 pi. So rather than repeating every 2 pi, my graph repeats every 4 pi units. All right. So now, one useful way to do this is to know what the graph of sine x looks like. And I'm going to draw the graph of sine x here. All right. So the graph of sine x looks like this. You have pi by 2, pi, 3 pi by 2, and 2 pi. And you go up 1, you go down -1. And your graph of sine x, so at pi by 2 it's 1, at pi it's back to 0, at 3 pi by 2 it's -1, and at 2 pi it's 0. So your sine curve looks something like this. So now, how do you draw this curve with the period 4 pi? Well, a period of 4 pi means that this one cycle, instead of ending at 2 pi, it should take up until 4 pi. So it's going to look something bigger, right? And now another way to think about this is that you think of it in the form of graph transformations, right? What does this mean? So if you have coordinates x comma y, that is going to change to your x coordinate is being stretched, right? There's a stretch factor. And what is the stretch factor? That is 1 over half times x comma y. And you will see that it's going to be 2x comma y. All right, so what you want to do is take every x coordinate here. 0, multiply it by 2, keep the y value same. All right, pi by 2, multiply it by 2, but keep its y value same. So you have 0, comma 0. Pi by 2, comma 1 will change to 2 because we had to do this, right? 2x changes to 2xy. Remember, whenever you have f of bx, that means that your x coordinates are stretched as follows. So if you have x comma y in the graph of f of x, then in the graph of f of bx, you are going to have 1 over bx comma y. That is how you do a horizontal stretch. So that is what you want to do. 2 times pi over 2 comma 1. And that just means pi comma 1. So pi comma 1, right? And if you do it with 2 pi, you are going to get, so you have 2 pi comma 0, and you get 4 pi comma 0, right? If you put pi here, pi comma 0 changes to 2 pi comma 0. All right, so 2 pi comma 0 here. So this point gets shifted here, and your graph looks something like this. It's going to be half a cycle because your period is 4 pi. So until 2 pi, you're only going to have half a cycle. So that is one way to think about how to draw this curve. And your amplitude is still 1. So your graph looks something like this. So this was the graph of sine x. This is the graph of sine of half x. All right. So that is how you do B. How do you do C? So you have y is equal to tan 3x. So nothing changes except the period. What is the period? Well, my new period, period, is going to be pi divided by 3, right? Pi divided by this value, so pi over 3. So now let's draw my tan curve. Tan 0 is always going to be 0, right? Tan 0 is 0. All right, that doesn't make a difference. So now let's find our first asymptote. Well, we know that tan pi by 2 is undefined, right? That is where our first asymptote used to be, at pi by 2. So let's set 3x is equal to pi over 2. So x is pi over 6, right? So your first asymptote is going to be at this point, when x is equal to pi over 6. All right. So now how do you draw your graph? Well, it's going to be positive. It's just going to look like this, right? And now your period is pi over 3. And pi over 3 is where your graph repeats, right? Tan graph looks like this. And it used to repeat for every pi, but now it's changed. The period has changed to pi over 3. So your distance between the asymptotes is going to be pi over 3. All right. So if I say that this is pi over 6, this is 2 pi over 6, this is 3 pi over 6. And 3 pi over 6 is pi over 2. So this is pi over 2. So that is where our next asymptote is going to be. And you can check. You put pi over 2 here. You get tan 3 pi over 2. And remember, tan is undefined for odd multiples, right? All right. So now you add pi over 3 again. You get another asymptote here. You add pi over 3 again. You get another asymptote here. So what are the points of these asymptotes? You have an asymptote at pi over 2. So then you have an asymptote at pi over 2 plus pi over 3. And that is 5 pi over 6, right? So you have an asymptote at 5 pi over 6. You have an asymptote at 5 pi over 6 plus pi over 3. That is just 7 pi over 6, I believe. Right? And you want to go do this up until 2 pi. So this is pi over 6. You can write this as 3 pi over 6, 5 pi over 6, 7 pi over 6. So you can see the pattern actually. your next asymptote is going to be at an odd. So this is 1 pi over 6, 3 pi over 6, 5 pi over 6, 7 pi over 6. So your next, sorry, not like this. So your next asymptote, and remember, they ask you for degrees, so you can always switch to degrees, but you can also just plot this graph for 2 pi. That is also okay. Usually if they give you in degrees, it's expected that you plot in degrees, but I'm going to do it in radians. And you can always just convert these values. Pi over 6 is 30 degrees, 3 pi over 6 is 90, this is 90 plus 60 is 150, this is 210 degrees, and so on. So let's find your next asymptote. It's going to be here. And in your next asymptote, it's going to be 9 pi over 6. And 9 pi over 6 is just 270 degrees. All right, let's draw our more asymptotes because we need to go up until 360, right? So I believe this should be the end. So after 9 pi over 6, you have 11 pi over 6. And this is beyond 2 pi. So I don't need to draw this asymptote actually. So now, how do you draw this? The curve. Well, the tan curve, in the middle of these, you're going to get a 0. So pi by 6, what is 3 pi by 6? If you take the middle values of your two asymptotes, you're going to get 0. Why? If you remember what the tan curve looks like. You had an asymptote at negative pi over 2. You had an asymptote at pi over 2. And your graph looks something like this. Right? So in the middle of the two asymptotes, you had a 0 point. And that is not going to change. So your graph looks like your pink curve. So the shape doesn't change, nothing changes, it's just going to look like this. All right. And you can just figure out the middle points. What is between 60 and 90? Well, that is 60 degrees, 30 and 90, 60 degrees. This is going to be 120 degrees, right? Between 90 and 50. So this is 180 degrees. This is 180 plus 60 is 240 degrees. This is 300 degrees. And this is 360. So you don't need to plot this arm. You only need to plot until 360. All right. So your graph looks something like this. All right. So that is your graph, which I didn't draw properly in the previous video. All right. So let's do D. Y is equal to 3 cos 2x. And I'm only going to use two facts here. I know that my amplitude is equal to 3, and I know my period is 2 pi over 2, which is pi, right? Now let me look at my regular cosine graph. My regular cosine graph looks something like this. Pi by 2, pi, 3 pi by 2. So I'm going to plot at 90. Usually I like to plot at 90. Right, so my regular cosine graph, let's say this is 1, looks something like this. So it goes, the maximum point is 1, the minimum point is -1, and it has these points, right? Period is 2 pi. So the shape of my graph does not change. What changes is my period. So this shape, previously it repeated for 2 pi, but now it's going to repeat for pi, something like this. And my amplitude is 3. All right, so now let me draw my curve. So it's going to go up till 3, down till -3. Now just plug in some values if it helps, right? Plug in 0. Cos 0 is 3. So you start up here, right? Plug in pi by 4. Why do I plug in pi by 4? Because if I plug in pi by 4 here, I'm going to get 2 times pi by 4 is pi by 2. So at pi by 4, you're getting 0. So another way to think about this is cosine or sine. It works with sine as well. So this is the graph of cosine, right? You can see 4 sections, starting from 1 and going down, then going from 0 to -1, from -1 to 0, and from 0 to +1. So you're going to have the same 4 sections, but instead of the section width being pi over 2, it's going to change to pi over 4. Why? Because remember, your x coordinates are multiplied by half, right? Because you have 2x, cosine of 2x. So your x coordinates get multiplied by half. So instead of this section being pi by 2 long, it's going to be pi by 4 long. And that is the idea. So this is pi by 4. Let's say this is pi by 2. This is 3 pi by 4. This is pi. And this is going to be 5 pi by 4. This is 3 pi by 2, I believe. And this is going to be 7 pi by 4. And this is going to be 2 pi. All right. So now, if you just plot the graph, remember, this is 45 degrees, 90. So how did I figure this out? I just sectioned it. I just made my width 1 by 4. 1 by 4, 1 by 4, 1 by 4, 1 by 4. Because we discussed this width was pi by 2. Sorry, yeah. My width is pi by 4 now. It's because this width is pi by 2. So now I need to do pi by 2 times half because we have cosine 2x. And so that means I multiply all my x coordinates with a stretch factor of half. I get pi by 4. So that is just how I sectioned off. And I need to plot until 360, which is 2 pi. So now my each section is just pi by 4 long. So I go from 3 to 0, 0 to minus 3, minus 3 to 0, minus 3 to 0, and back to 3. And that is it. Now I just need to repeat this. And yeah, we're done. This is how the curve of 3 cos 2x looks like. All right. So let me turn on my laptop so I can keep checking. But yeah, that is how your graph of 3 cos 2x should look like. And you can always plug in these values. You can always plug in values, multiples of pi by 2, pi by 3, pi by 4, because you know how to solve for these values. We have already discussed them at length. All right, so let me erase this. This tells me it's a regular cosine graph, but now it has an amplitude of 3 and the principal axis is different. All right, that is all I need to know. So usually my principal axis is my x-axis, right? When y is equal to 0. But we are given a different principal axis this time. My principal axis is y is equal to 1. So that is my principal axis. And yeah, and then basically I just need to plot for, because it's a regular cosine curve, I just can plot for pi by 2, pi, 3 pi by 2, and 2 pi. Because my period is the same. It's just 2 pi. So I can use these denominations for 2 pi. All right. So my amplitude is 3, and I'm starting at my 1 point, right? So I need to go 3 up. If I go 3 up, I reach up until 4, right? If this is 1, and my amplitude is 3, then I have to go up until 4. And I need to go 3 down as well. So I get to negative 2. All right. And now I can just draw my cosine curve regularly. I start at my maximum point. Cosine 0 is 1, right? Which is the maximum. Rather than my 0, I have to come down to my principal axis. And then at pi, I go to my minimum value. At 3 pi by 2, I return to my principal axis. And at 2 pi, I go up to my maximum value. Right? This is how the cosine graph usually looks like. And now I just connect my points. All right, so your curve looks like this. Pretty straightforward. And we're done with E. All right, and F is very, very similar. Our principal axis is negative 1. So that is the starting point. My principal axis is negative 1. So this is my principal axis. Now my amplitude is 2. So from negative 1, this is negative 1, I need to go up 2. So that is up until positive 1. And I need to go down 2. That is until negative 3. All right. And my amplitude is 2 and my period is 3x. All right. So that means my period is 2 pi over 3. Right? That is my period. So let me write it in denominations of pi over 6. Right? Maybe that's helpful. So if I draw my graph like pi over 6, so something like 30 degrees, right? That is pi over 6. So 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150, 180, 210. Okay, let me draw my axes to be longer. 210, 240, 270, 300, 330, and finally 360, right? All right, so we're plotting it in degrees. So now just plug in 30 degrees because I think putting in 30 here is going to give you sine 90 degrees, and sine 90 is 1. So 2 minus 1 gives you 1. So at 30 degrees, it's already at its maximum point. And 2 pi by 3, remember, is just going to be 120 degrees. So your period is at 120. So plug in 0 here, and you get negative 1. Right? So you start from your principal axis, you go up to 1, and now you can just figure out the pattern. Because if at 120 degrees, I need to be back at my principal axis, right? Because I need to finish one cycle. I need to come back where I started with. Yeah, I need to come back where I started at, right? So at 60 degrees, if I need to get back here, then I probably need to go to my principal axis again. At 90, I probably need to go to my minimum point so that I can be back here. So that's how I can complete my period, right? It makes sense. So, and then if I know one period, then I know every other point. So it's just going to go up again, come back down, go to its minimum point, come back to its principal axis, right? It's going to go up again, come back down to the principal axis, which is this one. Go back to its minimum point and come back, return to its principal axis. So my curve looks something. Okay, that is very bad. I can just erase this section actually. I don't need to erase all of it. So down to its minimum point, goes up. Okay, sorry, my bad. Goes, okay, I missed 2 points. That is why it's not working. So come back down, goes up, connects here, comes back down, and goes back to its principal axis. So that is how the graph is going to look like. All right, so I hope it makes sense. You just need to figure out how your graph looks like for one period, and you just need to figure out a good denomination for your axes. So usually, if it's 3x, I think pi by 6 is a good starting point, right? But yeah, that is how your graph looks like. All right. At 90, it's at its minimum point. At 180, it's back at the principal axis. And yeah, so this is how your graph for f looks like. All right, so now we're going to deal with translations. So if you have 45, usually it's just good to draw the graph for 45 as well. All right. So let me draw for pi by 4, pi by 2, 3 pi by 4, pi, 5 pi by 4, 3 pi by 2, and 2 pi. Right, so this is what my regular sine graph looks like, and it goes up 1 and down -1. So my regular sine graph at 3 pi by 2 reaches it. Sorry, at 3 pi by 2, I have 7 pi by 4 here, and then only 2 pi. All right, so my graph looks something like, my sine curve looks like this. Now I need to translate it by 45, 0, right? So 45, 0, or by pi by 4, 0 to the right, because we have x minus 45. All right, so let's just translate it. So how is it going to look like if I translate it by 45? So remember, I just need to shift every point by 45. So this point reaches here. This point reaches here if I translate by 45, right? This point-ish reaches here, right? This point gets, sorry, this point gets shifted by 45, this point gets shifted by 45, this point gets shifted by 45, this point needs to get shifted by 45. So So this point here. And this point needs to get shifted by 45. So there. And this point needs to be shifted by 45 here. And let's see. So let's draw this roughly, right? This point starting point also needs to be shifted by 45. So we have here. So let's connect what we have. And now we need to draw the remainder, right? So how is the remainder of the graph gonna look like? Well, so it's gonna look something like this. Because if you plot 0 here, you get sine negative 45. And sine negative 45 is sine negative 45. So negative 1 by root 2 is not, it's going to be less than negative, it's going to be greater than negative 1. So it's going to be somewhere here. And then up until 2 pi, because the period of this graph is still 2 pi. So this point, you have to match it here. So your green curve is going to go up until this here. All right, so your graph looks something like the green curve. So you can erase the pink curve now, because the pink curve was just there for reference. There's erase the pink there, erase the pink here, and then erase the pink here. So something like the green curve. That is your solution. So this is pi. Yeah, something like this. So it's a rough sketch. So this is admissible. All right. So, and basically everything else is the same. So I hope this was helpful. I'm going to leave the last 2 questions for you so that you can do H and I. I'm going to leave it to you. I is very straightforward. Yeah, so let's just do I. I'm going to leave H for you, because I, you just want to shift your asymptotes and the shape stays the same, right? X minus 90 means you just shift all your asymptotes by pi by 2. So your first asymptote occurred at, you had an asymptote in negative pi by 2, so that shifts to 0, right? That asymptote is here. You have an asymptote, you used to have an asymptote at pi by 2, now you have an asymptote at pi. And you also have an asymptote at 2 pi, you're going to find out. Because you had an asymptote at 3 pi by 2, so you need to shift it by pi by 2. So this is pi, this is 2 pi, and your graph, in the midpoint, you're going to have 0. So your graph looks something like this. Very simple. Sorry, so this is too small. I messed up my axes. So 4 units pi, 1, 2, 3, 4. So this is 2 pi. All right, so your graph looks something like this. All right, so that is your solution to the last question. So this is 270, or 3 pi by 2, and this is pi by 2. All right, so I'm going to leave this question to you so for practice. And that is it. That is all that I have for this topic. And we're going to go do inverse trigonometric functions next.